Hello viewers, welcome to JSM. In this lecture, we are going to discuss EAMCET previous year solutions, and the topic is structure of atom and year 2021. Okay, so let us see the first question. The number of protons, neutrons and electrons present in 6 carbon 13 respectively are. Okay, so here given that 6 carbon 13. Okay, see here, what is this? This is nothing but the atomic number. And what is this? This is mass number. Okay, denoted by A. Right, so here atomic number means the number of protons present in the atom, or this is also equal to number of electrons present in the neutral atom. Okay, atomic number is maybe number of protons are equal to number of electrons in the neutral atom. So that's why here atomic number is 6. So that's why number of protons is 6. Okay, and number of electrons is also 6. And what about the number of neutrons? They ask you to find number of neutrons also. Number of neutrons equal to mass number minus atomic number. Okay, A minus Z will give the number of neutrons present in that atom. Okay, so here mass number is 13, atomic number is 6, so here we get number of neutrons equal to 7. Okay, so first option is correct. So number of protons 6, number of neutrons 7, number of electrons 6. Okay. Next, the masses of an electron, a proton and a neutron respectively will be in the ratio. Okay, see here, these are the masses of electron. We know that all these values, mass of electron, proton and neutron. Okay, so if we see these, the mass of a proton is 1836.15 times heavier than the electron. Okay, and similarly mass of neutron is 1838.68 times heavier than electron. So their mass ratio will be 1:1836.15 is to 1838.68. So first option is correct. Okay. Next, which of the following species with the correct number of electrons present in them? Okay, so here 4 ions are given. We have to find the how many electrons are present in them. So here first beryllium 2 place. See here, first we should write how many electrons present in the neutral atom. Beryllium atomic number is equal to how much? 4. Means 4 electrons are present in the neutral beryllium atom. So 2 plus means 2 electrons are removed from these 4. So just write minus 2. So we get 2 electrons are present in the beryllium 2 place. Next H place. Okay, so what is the atomic number of neutral hydrogen? 1. Means 1 electron is present. Plus means remove 1 electron. So here we get 0 electrons are present in the H place. Okay, now next sodium plus. So what is the atomic number of sodium? 11. So Na plus, remove 1 electron. So here 10 electrons are present in Na plus. And next magnesium plus. So what is the atomic number of magnesium? 12. Okay, so from that plus means we should remove 1 electron. So here we have 11 electrons. Okay, so beryllium 2 plus has 2 electrons. So for A 3 and H plus has 0 electrons, for B 1. So like this. So option D is correct one. Okay, just very simple here for this type of questions. First write the total number of electrons in the neutral atom and then remove the electrons if positive charge is present and add the electrons if negative charge is present. Okay. Next, so match the following. So here scientist name is given and what they did. Okay, see here Chadwick, he discovered the neutron. So for Chadwick, what is the correct matching? Discovery of neutrons. Rutherford, he proposed the nuclear model of atom. So for B, fourth one, Mosley, X-rays spectra, and J.J. Thomson explained cathode rays. So here option D is correct matching. Okay, A3, B4, C2, D1. Next, the spectrum of helium is expected to be similar to that of. See here 4 options given and similar to that of helium. Okay, see here Next, the spectrum of helium is expected to be similar to that of. See here, 4 options are given, and similar spectrum, which of the following has as helium? Okay, so here, if they have equal number of electrons are same, then their spectra will be similar. Spectra will be similar. Just like we calculated in the previous question, so here we should calculate number of electrons present in them. Okay, so helium, what is the atomic number of helium? 2. Okay, so number of electrons are present in the helium is 2. Next, lithium plus. Lithium atomic number is how much? 3. So we should do 3 minus 1. How many electrons? 2 electrons. So lithium plus has 2 electrons. So that's why lithium plus and helium expected to be have similar spectra. So option A is correct. Similarly, see here for hydrogen, neutral hydrogen, 1 electron, not equal. Sodium, 11 electrons, not equal. Helium plus means 2 minus 1, 1 electron. So that's why option A is correct one. Okay. Next, on the basis of Bohr's model, the radius of the third orbit is. Okay, so here from the Bohr's model of atom, we know that radius equal to A naught into n square. A naught into n square. Okay, so here this is the Bohr's radius A naught, that is the radius of first orbit in the hydrogen atom is called as Bohr's radius. So from this we can write that as Rn is directly proportional to n square. So here see options, look at the options. The radius of third orbit is equal to the radius of first, 3 times to the radius of first orbit, like that given. So that's why here let us take the ratio radius of first orbit by radius of third orbit. So we get n1 square by n3 square, right? Okay, so if you substitute here, we get R1 by R3 is equal to n1 square, first orbit, so 1 square, n3 square, third orbit, so 3 square. So here we get R1 by R3 equal to 1 by 9. So if we simplify this, we get R3 equal to 9 into R1. So radius of third orbit is 9 times to the radius of first orbit. So option D is correct. Okay, so remember this formula, very very important. Many times questions were asked in the EAMCET. Next, the energy associated with the electron in the first orbit of lithium 2 plus is. Okay, so again from the Bohr's model, what is the expression for energy? Minus 13.6 into Z square by n square electron volt. So here they ask you to find in the electron volt, so that's why we are taking this. Okay, so if you substitute here, see what is the species given here? Lithium 2 plus. Okay, for lithium atomic number is 3, and here also given as energy in the electron in the first orbit. So n equal to how much? N is equal to 1. Okay, so let us substitute here. Energy equal to minus 13.6 into Z square, 3 square by n is how much? 1 square. Okay, so E equal to, we get minus 13.6 into 3 square is 9. So here after simplification we get minus 122.4 electron volt. So option A is correct here. Okay, see this is also one of the most important formulas which is a very very useful. So many times questions are asked in EAMCET related to this formula. Next, two particles of masses m and 2m have equal kinetic energies. The de Broglie wavelengths are in the ratio of. So here from the de Broglie's theory we know that wavelength equal to h by square root of 2 into kinetic energy into mass of the particle. Okay, so here for the first particle wavelength is lambda 1. So this, if we substitute here h by Next, two particles of masses m and 2m have equal kinetic energies. The de Broglie wavelengths are in the ratio of. So here we know that from the de Broglie's theory, wavelength equal to h by square root of 2 into kinetic energy into mass of the particle. Okay, so now for the first particle wavelength lambda 1, that is equal to h by square root of 2 ke into m. Okay, and for the second particle h by, see here h is a Planck's constant, so that's why h, and here also h. Okay, 2 into ke. See here it is provided that both have equal kinetic energy, so that's why here and here kinetic energy is same, so simply I am writing ke. And the mass of the second particle is given as 2m. Okay, so now therefore if you take the ratio of the wavelength of two particles lambda 1 by lambda 2, so here h and h will get cancelled, 2 and ke, these will also get cancelled, yes or no, because both have same kinetic energy. So finally here we have square root of 2m by root m. Okay, so here m and m also will get cancelled, so finally we have lambda 1 by lambda 2 equal to root 2 by 1. Okay, so the wavelength ratio is root 2 is to 1, so option D is the correct answer. Next, with what velocity must an electron travel so that its momentum is equal to that of a photon of wavelength 663 nanometer? Okay, so here we know that from the de Broglie's theory, wavelength lambda equal to h by mv. Okay, see if we rearrange this, we need to find out the velocity, right? So that is equal to, from this, h by m lambda. Okay, just we rearranging this one. So here wavelength is given as how much? 663 nanometer. We should convert it into meter. So that is 663 into 10 power minus 9 meters. Okay, so now here if we substitute h, we know that, and v equal to h 6.626 into 10 power minus 34 joule second, and mass of the electron is how much? 9.1 into 10 power minus 31 kg, and wavelength is equal to 663 into 10 power minus 9 meters. Okay, so after simplification we get 1098 meters per second. The velocity of the electron is 1098 meters per second. Next, if two particles A and B are moving with the same velocity, but wavelength of A is found to be double than that of B, which of the following statement is correct? So here from de Broglie's theory, lambda equal to h by mv, just now we discussed in another question also. So for first particle or particle A, lambda equal to h is a constant, so write h by mass of A into velocity of A. Okay, and for particle B, wavelength equal to h by mass of B into velocity of B. See here two conditions are given, that what are they? Both A and B are moving with the same velocity, means so velocity of A equal to velocity of B, right? Okay, and what is another thing given? Wavelength of A is double that of wavelength of B, so lambda A equal to 2 into wavelength of particle B. Okay, so if you substitute here, this is h by MA VA, that is equal to 2 into h by MB VA. See here VA equal to VB, so just I substituted in place of VB VA. Okay, so h will get cancelled, these are also will get cancelled, so finally we have see, after rearranging this, we get mass of A, particle A equal to mass of particle B divided by 2. Yes or no? So here option B is correct. Mass of A is half that of mass of B. Next, A microscope using appropriate photons is engaged to track an electron in an atom within distance of 0.001 nanometer. What will be the uncertainty involved in measuring its velocity? Okay, so here we use Heisenberg uncertainty principle concept, and that is, according to that principle we know that uncertainty in position into uncertainty in velocity is greater than or equal to h by 4 pi m. Okay, so what is here m? Mass of the particle. So here it is given that uncertainty in position is given, right? So that is equal to 0.001 nanometer. If you convert it into meters, 0.001 into 10 power minus 9 meters, that we get 10 power minus 12 meters. This we can write as 10 power minus 3, right? Okay, and mass of the particle here, what is the particle? Electron, so that is 9.1 into 10 power minus 31 kg. Okay, so now here let us substitute all these in this. So we need to find uncertainty in velocity, right? So therefore delta V equal to, by rearranging this, h by 4 pi m into delta x. Just we rearranged this. Okay, now let us substitute all these values here. h 6.626 into 10 power minus 34, pi is 3.14, and mass is 9.1 into 10 power minus 31 kg, and delta x we got here 10 power minus 12 meters. Okay, so after simplifying this we get option A as the answer. Okay, see here, to save the time I am not going to simplify all these all you can do. Okay, only thing here I am mainly focusing on how to approach the question and what formulas we should use, like that. Okay. Next, Heisenberg's uncertainty principle is in general significant to. See here, 4 options are given: planets, cricket ball of 500 gram, cars, and microparticles having very high speed. Okay, see, Heisenberg uncertainty principle is not applicable for the macro objects, means very big objects, and also not applicable for the particles which are at rest. It is only applicable for microparticles moving with high speed. So that's why here option D is the correct answer. This is a conceptual question, no need to use any formula or anything. Okay. Next, which orbital among the following has 0 radial nodes and 2 angular nodes? Okay, see here, number of radial nodes, what is the formula? N minus L minus 1. Okay, and for number of angular nodes, what is the formula? That is equal to azimuthal quantum number L. Okay, so here we should find the number of radial nodes. See, for 4s orbital, N is 4, for s orbital L equal to 0 minus 1, so that is 3. And number of angular nodes is equal to 0, L equal to 0 for s orbital. Okay, and 3D. In the same manner for every orbital you should check. So 3 minus, for d orbital L equal to 2. Sir, no, for d orbital L equal to 2. See, for s orbital L equal to 0, for p orbital L equal to 1, for d orbital L equal to 2, for f orbital L equal to 3. Okay, so here 3 minus 2 minus 1, that is equal to 0. 0 radial nodes, 2 angular nodes. Okay, and here see, which of the following has 0 radial nodes and 2 angular nodes? So here 3D orbital has 0 radial nodes and 2 angular nodes. So option B is correct. Similarly, you can check for these two also. Okay, see, these two formulas, these are also very, very important. Almost every year they have asked one question. Okay, so many times questions are asked regarding these two formula. Okay. Next, the number of radial nodes in 3s and 2p orbitals respectively are. See, again the formula is number of radial nodes equal to, so here we got 2 times, number of radial nodes equal to n minus L minus 1. Okay, so 3s and 2p orbital. So for 3s, See, for 3s radial nodes, n is 3. For s orbital, L equal to 0 minus 1, that equal to 2. Right? For 2p orbital, n is 2, L equal to 1 minus 1, that is equal to 0. Okay? So what is the correct answer? Option B is the correct one. Okay? 3s orbital has 2 radial nodes and 2p orbital has 0 radial nodes. Okay? Next, an orbital with one angular node shows 3 maxima in its radial probability distribution curve. The orbital is. Okay, so here, just now we discussed number of angular nodes equal to L and number of radial nodes equal to n minus L minus 1. And here, see, this is very, very important. Remember this, number of maxima in radial probability distribution curve equal to n minus L. N minus L. Okay, see, these are the diagrams. So for our question, it is an orbital with one angular node, means that is definitely a p orbital, yes or no? For p orbital only angular node equal to 1, right? So that's why here you can eliminate these two options. So answer may be either 4p or 3p. Okay, very clear. So we can eliminate these two options immediately. And now, so here n minus L. Right. See here, for 4p, 4 minus 1, that equal to 3. And for 3p, 3 minus 1, that equal to 2. So what is the answer? 4p. Okay. So it has 3 maxima. Okay. Right. See here, for 1s orbital, we have only one maxima. Right? 1 minus 0, n minus L. What is the formula to find number of maxima in the radial probability distribution curve? N minus L. So 1 minus 0, 1 maxima we have. See, if you consider 2s, 2 minus 0, 2 maxima. This is 1 maxima and this is another maxima. Okay. So for 2p, 2 minus 1, 1 maxima. For 3s, 1, 2, 3, 3 maxima. 3 minus 0, 3. Okay, so like that. See, for our question, this one, for 4p, 1, 2, 3, 3 maxima. Yes or no? 4 minus 1, 3 maxima we are getting. Already we calculated here. Okay, clear? So these two already we discussed just now. This is another one very, very important. Clear? Next, the orbital with 4 radial and 1 angular nodes is. Okay. So number of angular nodes is L, number of radial nodes equal to n minus L minus 1. Just now we discussed it. Okay. So one angular node. See here, again you can eliminate these two options. Yes or no? Because for p orbital only one angular node is present, and now we should check 4 radial nodes, which will get the 4 radial nodes. So for 6 pz, okay, 6 minus 1 minus 1, that is equal to 4. So this is our answer, and this one 5 minus 1 minus 1, that is 3. So what is the answer? 6pz orbital. Okay, clear? So in the another lecture we discussed 2022 questions.